Hello everyone, am I audible right?
Yeah, Swagat here.
Hello everyone, hope you are doing great. My name is Swagat, Business Development Executive from Advantage Learning. We welcome you all, guys. We are about to start our workshop. We really appreciate your effort to take out your time. We will make every effort to make this informative for you and we will give as much as information as possible. I would like to introduce our faculty member, Mr. Jaiyesh Chahar, a data scientist expert at Siemens Company. He has more than 10 years of experience. Guys, if you have any query, please feel free to ask. That's all from my side. Jay sir, the mic is yours. Thank you.
Yeah, hello, all amigo. Good evening, good morning, good afternoon. Hope everybody is doing good, having great time, learning new things. I'm audible to all, right?
Yes, sir.
Okay, so today our session will be more of an interactive session. So I will be expecting questions, queries, or not only questions, queries, response from you guys, basically. So the topic, let me share my screen. And as in 1 hour we will not be able to complete the whole project itself, so I have created a ppt for the different portion of the project that we are going to discuss. Let me share the screen. Please let me know once my screen is visible.
Yeah, it is visible.
So I have given the name that it is extreme anomaly detection and forecasting, but yeah, normally in our scenario will be predictive maintenance or the failure of the equipment. So first of all, what does predictive maintenance mean? Just give me a second. Let me get my uh, tablet to it so that right, guys. You can please mute yourself if you don't have any query. It will be disturbing for others.
What can make man noise without sunshine?
Okay. So what the topic of discussion is what? Predictive maintenance, right? Predictive maintenance, you can say, or failure prediction, you can say. How many of you guys have idea what exactly is predictive maintenance? Just write in the chat box how many of you guys have the idea what is predictive maintenance. Just say yes or no. If you don't have an idea, just write no in the chat box. Okay, AFM has idea. Others? Correct, Claudia. So predictive maintenance basically means that we are predicting that when, let's say I have a equipment, let's say I have a compressor. Okay, I have a compressor here. This is my compressor. I have historical data of this particular compressor, or I have some, let's say, vibrational data of this particular compressor. By using that data, if I'm able to tell that, okay, in coming 7 days, a part of this particular compressor is going to fail. Let's say it has four parts, A, B, C, and D. So from looking at the data, if I said that in 7 days, my part A is going to break. So I know 7 days in advance that my part A is going to fail in the coming seventh day. So what I can do, I can plan or I can plan my maintenance of this particular equipment in advance. So I will order this part A. Okay, I will order this part A in advance itself. I will get the mechanic or the guy, engineer guy who is expert in working with this part A, right? He will be ready, all things will be ready. So once if my part A is going to fail, when my part A is going to fail, I have all the things ready so that My downtime, because if part A has failed, your compressor will stop working, right? So if I know in the advance that the compressor is going to stop working, all the things are ready, my downtime, which is the time when compressor is not working, will reduce, because I will already have part A as well as the engineer who is going to fit this part A, right? So by using this PAM, predictive maintenance, we can reduce our downtime, or also we can see that, okay, if there is some problem with part A, if I can fix that. So you can reduce your downtime, or you can see your machine beforehand that what is going to fail. So that's why predictive maintenance is important in the industry, so that we get an idea when our equipment is going to fail. Okay. Now with the advancement of your deep learning, machine learning, or even instead of machine learning, deep learning, let's say with the advancement of your AI techniques, this thing has been automated a lot in the industry nowadays, because of the use of this AI, we have historical data. We will be able to predict that, okay, when my equipment is going to fail. So that my friend is predictive maintenance. So basically, we are predicting the failures also, right? Beforehand. There are also some of the conventional methods for different equipments. If a physics guy is present there, he may know that, okay, when equipment is going to fail by looking at the compressor data or different data. Okay. And once we have predicted the maintenance, you can also do the preventive maintenance also. Preventive basically means the thing that I said, that I will look into part A and get to know, okay, when this particular part is going to fail. And as this particular thing is important in oil and gas industry, it has a lot of importance in oil and gas industry, because you guys know there are many remote offshore platforms. There are many remote offshore platforms are also present, right, in the deep sea environment and there. And if I know that in this particular platform, if there is some equipment, there is something that is going to fail in coming few days, let's say 7 days. So I will pre-handly manage this particular equipment, right? I will call the inventory that, okay, guys, I need this particular equipment in coming 7 days. Please deliver it to this particular platform, right? So that will help to reduce the downtime, as well as economically also it is very beneficial. For example, I am producing oil somewhere, and because of this particular equipment, right, my oil production stops, let's say for 10 days, it has stopped because for 10 days my equipment requires 10 days to arrive, right? So how much loss I have costed? My company has made a lot of loss in these 10 days, right? So this 10 days loss, I may recover. I can reduce this value by 3 days if I know before the 7 days itself that this is going to fit. Okay. Is it clear to all that what a predictive maintenance, preventive maintenance means? But is saying yes, clear. Others, please respond. As I said in the starting, I want this particular session to be interactive. It's not just because that, okay, there is a session, let's attend it. Yes or no? Great. Mustafa is there. Yes, Ignesh. Great, guys. Great. Yeah, this type of interaction I want in this particular session. So now coming to our project, I will also show you the code, but as the code is having many notebooks, because again, the data science project is a vast project. It has different number of stages. So all the things we may not be able to discuss. That's why we have this particular PPT. Okay. So So what my problem statement looks like? Okay, so let me give you brief of the problem statement. Here I have a data from IoT sensors. I have data of a compressor. This is compressor itself. Data compressor from different sensors. I have the data. Okay, sensor names I don't know. What are the sensor names? I'm not telling the sensor names. No discussing here. But I have sensor data and also historical data is there. Historical sensor and failure data is there. Sensor and failure data. That okay, when your machine is failing, when your compressor is failing, that data is also there and sensor data is also there. Okay. So data used, you can see time series sensor data of an equipment and class describing the state of the equipment. Basically, whether your equipment is performing normally, is it in normal state, or if there is some failure. And if there is a failure, as we knew that if there is a failure, recovering from failure state also takes time, right? For example, if equipment A is not there, for getting the equipment A, then using it, it will take time. Missing data is also present there, but failure data is not the missing data. With two, failure data is different. Missing data is that you don't even have the data during that particular time. I'll show you the plots, you will understand. Do we have to assume the same technical specs for the compressor? Actually, this particular data that we had, this is of the same compressor itself. And from the sensors data, we are just fine that if we are able to get some relationship or forecast or something. Okay, FM. Okay. So now the next thing. Yeah, and the objective I will written by predicting failure before some time downtime can be reduced or why failure can be prevented. Now, how does the project workflow or life cycle of a project look like? This type of project. First of all, we will doing the EDA, exploratory data analysis. Basically means the data that I have, I will do investigation on that particular data. Investigation on the data so that I can know what exactly is happening, how many missing value do I have in my data, if my data is wrong or right, what exactly is happening. So EDA, you got the data, you don't know anything about the data, you will look into data, right? So that step is your EDA. After that, we will be clearing the data cleaning and preparation part will come. Once this is done, then as in this our situation, there are 50 sensors of data is there. So not going to use all the 50 sensors because there are some sensors that are kind of interrelated with each other. And there is this particular term used in machine learning, multicollinearity. So there can be multicollinearity in the features. If you want to know what multicollinearity is, we can discuss later. But yeah, we'll not use all the 50 sensors. We will do some feature selection, do some sensor selection and use them. Then we will try different models. And again, in machine learning, AI, there can be different models. There can be shallow machine learning model, shallow ML models, like random forest, decision trees, sport vector machine, XGBoost. And there can also be deep learning models like LSTM, long short-term memory, RNNs. Different, these are just the name of different algorithms for different models. Okay.
टेक क्लास का मतलब सिर्फ यूट्यूब का वीडियो टेक क्लास में ले 2 घंटे का
नहीं इसमें कुछ नहीं सीख पाऊंगा।
तो वो तब तक
we-
बेसिक को बताता हूँ प्रैक्टिस नहीं।
okay, please guys mute yourself if you don't have any doubt. Don't make unnecessary noise in the session. Okay, different model we will try, and we'll see that our data is a time series data. So LSTM and RNNs will kind of give more better results as compared to shallow machine learning model, because they do not consider the dimension of time, do not consider
पेमेंट का लिंक
dimension of
मिलेगा।
time.
पेमेंट करने के बाद क्या तुमको लिंक आएगा।
To him, do you have any doubt? No. Okay. So now, once model identification is done, then metric selection, that okay, which metric I have to use to see how my model is working. Then model training. Okay, no worries. Model training will happen. We'll train our model. We'll test our model on our testing set that okay, if it is giving good result or not. And then at last performance evaluation. Let's see. Initial step EDA, exploratory data analysis. So let me first show the code, then we'll come to this particular thing. So for example, these are some of the functions that I have written to visualize the data, visualize the sensor data, or to interpolate the values to fill up them. These are just the functions, normal Python functions, nothing else. Okay. So my data is looking like this. You can see around 50 sensors are there. 15, not 50, 52 sensors are there. And this class is basically telling me the state of my thing. So here you can see class are having three values, 1, 3, and 0. 1 is your normal class, 3 is your recovery class, and 0 is your failure class at which your failure happened. So total 7 failure points are there in my data. Total these many points are the recovering points, and this particular thing is my normal class. Okay. And here you can see the null values, 49, sensor 40, this I guess is 50, is having a lot of null values, right? Apart from them, null values are okay, not that much. Sensor 0 is also having high null values, I guess 10,000 null values. And around how many? Around 2,20,000 data points I have in my data. Okay. So sensor 0, you can see have 10,000 null points, and 50 have 77,000 null points. Apart from them, there are very less. So those we can fill up easily by interpolation. This just I'm saying the statistics of my data so that I can know which sensor is having what range. For example, sensor 0 is having the range from 0 to 2.5. Sensor 1 is having range from 0 to 56. Again, 0 to 56. Just getting the idea how my sensor values are looking like. And then just I'm visualizing. For example, this sensor 51 was having a lot of basic values, right? Here, this one. I visualized how the sensor 51 is looking like. So this type of data is there, and here null values are there. And you can see a very high spike here. So there can be chance that there is something happened here, right? Similarly, for sensor 50, I have seen you can see this completely thing is null. Again, chance that something may have happened. Should I use this or not? But later on, if you see the both of these sensors are having kind of similar pattern, this and this till this point. Maybe I can use these particular values to fill these values also. That can also be one solution. Sensor 7, you can see looking like this. Different sensors, I'm just seeing how they are looking like sensor values. Okay. Now what I am doing, I am just using my plot that using my function that I have plotted. So basically these red points are my anomaly points. I am plotting a sensor. Here sensor 8 I have plotted, and red points are my anomaly points where defect has happened in my compressor. Okay. and green are my recovering point basically. Okay, so I just wanted to see that if there is some pattern in any sensor, how graph suddenly means because I'm scrolling up and down. That's why it has changed. And I have written a function there. This function. Um, these are basically some code I have written, nothing else. I will not go into the depth of the basic Python code. Okay, just try to understand. Because again, Python, if you need to start from scratch of Python, that you have again will take a lot of time. Okay. I'm just trying to visualize what exactly is happening in sensors if I am able to catch them visually, the defect visually, right? So not able to capture it exactly. And this is my complete plot of different sensors. Now from this plot, you will understand, or I will understand that if you see sensor 6, 7, and 8 having the same thing. So maybe these are the some pressure sensors that are located nearby, 7, 8, and 9. So if I'm going to train a model, I'm not going to select all of them. I will just take one. Similarly, sensor 10, 11, 12 is also having similar thing. 14, 16, 17 is also having similar thing. 19, 20, these are also similar. Okay. Maybe scale may differ. Scale may differ. You see, the scale is different because these both are looking same, but scale is different, right? Scale, but if we take all of them in between 0 to 1, scale will become same. So main thing of machine AI algorithm that understand is the feature that what this feature is representing. So range will have no effect. Okay. And this one is my class. So this drop you can see is my point where my machine has failed, and this is my recovering point, and this is my normal point. This particular point is my normal, the straight line, and this is my anomalies basically. Okay. And I have written some of the observation. Again, this complete project may take more than 1 month. So that's why I'm not getting in depth. I'm just showing you that how EDA works basically. So coming back to our slide, we did null value analysis. We see the data distribution. We analyzed the data. If you see here, the green point is recovering point. So if for this particular sensor, if you see, if there is some drop in the value, that has resulted in means that has shown a failure at that point. So maybe that can help. And this particular plot, this is a correlation plot that will basically tell me that, okay, which sensors are similar for recognizing the sensor having similar pattern. So these are the set of similar sensors. We also saw the plot. These are the sets. Now by using this set, we will be doing our feature selection. Okay. And here I'm showing how I have handled missing values. So I have missing values.
But when you focus, when you work easy.
So we have used the interpolation for doing the filling the missing values. Linear interpolation we have done. Some of the sensors are having the highest count of the missing values. You can see 6, 7, 8, 9 are having missing value near fifth of failure. And values present at the extreme of missing part is 0, and many other sensors are also 0. So these sensors are imputed by linear interpolation, nothing else. And as 50 and 51, we saw both were having same type of thing. So we used each other's data itself for filling the null values. Again, depending on the null values and depending on the features, different techniques again you can use for filling the null values. There is no hard and fast rule for filling the null values. Next, let's say I have filled my null values, right? Now, next step that comes in picture is data cleaning and preparation. So let me just quickly show that at last what we did. Just seeing the plots. Correlation I have used for a Spearman rank matrix. Okay, looking like this. So the lighter the value, more correlation is there in between your sensors. So you can see these sensors are having these three sensors heavy correlation. These sensors heavy correlation, right? Darker the value, no correlation. Lighter the value, high correlation. Just visualizing, nothing else. The story I already told you. Then I also created a similarity index function. Basically, in this, we are just taking the inversely proportional to similarity of sensors. Smaller the value of sim index, more similar the sensors are. You see, yeah. So basically, I have taken two values and just getting their absolute values and taking them there. Okay, so I have also created this particular same type of thing here I have created, but here the thing is that more blacker your value, more similar your sensors are. So from here I got this particular list that I already shown you. If so, do you have any doubt? You are again and again unmuting yourself. If you don't have any doubt, please mute it. Okay. So from these we will select our thing. And at last I have filled the null values. So basically having the similar structure, I filled this by 0 and basically in handling null values, I have done the same thing that we have seen there. Nothing else. Interpolation I have used to fill most of them. And by end of this particular notebook, our cleaned, or you can say null value handled scaled values thing has been prepared. Now the next step that came into picture is your feature selection or data cleaning. Data cleaning we already discussed. And what we did, one more thing that I did is that the basically in starting, if you remember, I have 3 points: normal, anomaly, and recovery. I have converted that into 2 points itself: normal and anomaly or recovery. So this particular point, if there is anomaly or failure, my thing is not working right in that during that point, during that period. So I have given that particular thing in one class itself that okay, these are my points when my machine was not performing, not working. And resampling I also did because I guess I had values in every 10 seconds, so that I have converted to 20 minutes, so that computation time will reduce. Now feature selection, basically different approaches that can be tried. You can do feature selections from algorithms itself, like random forest, extra classifier. Apart from them, we have also seen that which features are kind of more interacted with each other. So we can do the feature selection in them from them also. And PCA you can also use. PCA is a principal component analysis. So basically you can make the principal components from your original features and you can reduce your features. So in feature selection, first of all, this we made. Then here you can see from random forest I tried that which features we can use. Boolean has came 10. These 10 features it has given. From extra tree classifier, table has made that which features to take. So these are basically the features that we will be taking. These features. Okay. Now, once we have features, then we can try different models, starting from the shallow machine learning. So, okay, so different shallow machine learning models you can try. You can use PyCaret also to run in one go itself and see how your result is coming. This is basically PCA. I have converted my features into less number of components. In my originally 50 features were there, but I have converted them to 12. Okay, and I will be using these 12 features for my shallow machine learning training. So my accuracy was looking like 99%, but again, you cannot tell if you have an imbalanced data set, just like this. You cannot use accuracy to tell how your model is performing. You need to use precision and recall. So precision was less. Okay. Basically, it was also giving false positives. These are different models, just trying the models. Models you can try anyone. Okay, any model you can try. So the thing that happened was we were also getting good result, okay result from the shallow learning models also. But what comes into picture here is the fact that our data is a time series type of data. There is time dimension also. And your shallow learning models never understand time. Okay. If you see, they are not performing well because data is time series and they are not able to understand the sequence of events. So here the time series models comes into, and there are different time series models. There are statistical time series model like ARIMA, ARMA, and ARIMA different again models. And there are machine deep learning models also like RNN, LSTM. And nowadays, if you guys have heard about transformer you can also use to predict, to forecast the future. Okay, so that's why LSTM, so the time series model will perform well because there is a time dimension and your shallow learning models are not able to capture that time dimension. Metric selection, I just have told, precision we need to take, recall we can only accuracy you cannot take. Then model training, different models that we train. I have also trained the LSTM in this for this particular project. You can train LSTM other than anything you can train. Data preparation step, I will not again get into depth of the data preparation right now. Because again, explaining the complete data preparation step is itself a 2-hour job, but we have to complete all the things under 1 hour. So I'm giving you an overview how predictive maintenance can be done. And these are some of the examples of your LSTM. One is your many to one. So basically, previous days data you will take to predict that, okay, only in future if your equipment is going to fail or not. Another one is many to many. Previous many days data you have taken to predict your forecast in future many days. Here only future 1 day you have forecasted. Here you can forecast into many days itself. At last, just testing the model. So the thing that we are having here, around 1, 2, 3, 4, 5 failures we took for the training part and 2 failures we took for the testing part. And your single stem LSTM model performed well on the testing data. So it was able to detect both the abnormal duration present in the testing set. Now, if you want to forecast also in future that, okay, in future for coming end days, if it is going to fail or not, you can do that also. Here you can see I have forecasted, but there is no failure point after this point, right? For single step single step LSTM and multi-step LSTM. So it is basically telling that it will not fail for the coming days. Not coming days, the next 3 hours it is not failing. So basically this algorithm will tell you 3 hours prior to your failure. But if you have enough data, you can also make an algorithm that may tell you 2 to 3 days prior to the failure. Okay, here the scenario was we had very less data points of failure. That's why we are not able to forecast more than 3 to 4 hours. But if you have enough historical data, you can do the thing. So in this way, you can create your own predictive maintenance application where you can forecast the behavior of your machine, how it is going to act in the coming days. I'll quickly show you the code of LSTMs also. Basically used TensorFlow for training the LSTM. So these are your sensors data that were used around how many sensors I used? 1, 2, 3, 4, 5, 6, 7. One sensor data we used to forecast that, okay, whether these are going to fail or not. Okay. Created the data. So this is your 5 failures are in your training set, 2 failures in your testing set. This is your model creation. This is your model fitting. Basically model training. Then this is your prediction. Okay. Original one is with blue line that is not visible because it is below this. Predicted one This one, red one, and the green one are your predicted testing. Performance metrics, you can see precision was coming okay, default was also okay. Great means 98% precision is a great. And then multi-step LSTM used for forecasting to 3 hours in future. Forecasting into future. So here you can see this was the forecasted value. No failure was detected. So from where we'll get this data for predictive maintenance? Just right here, compressor, failure, data. Kaggle. There you go. If it is the particular data, not you can get from the Kaggle. There are many predictive maintenance data. Just search the Kaggle. The one that I am sharing that I cannot share because it is a little bit confidential. That's why I also in the name of just open Kaggle and search predictive maintenance. That's all. You will also be able to find the code as well as data. Let's test this out. Try to develop your own thing. Now, this was regarding this particular project where we talked about predictive maintenance using time series. Now, again, if you want to know more about the time series, so there is this particular Edvantage course that is coming on in coming few weeks that is going to start. Oil and gas forecasting and prediction using time series analysis. So in this, basically, we will be discussing different time series components. We'll be discussing a little bit mathematics, okay, and different terminologies of time series, like what is periodicity, white noise, how a times basically how a time series problem can be attacked or solved. Okay, so that thing we will be discussing all the different scenarios. As I said, some statistical models are there, the RIMA moving averages, those we will see. What are the different tests that we will learn, and also deep learning and LSTMs we will also see. And in the advanced, we will also do projects, different projects. So again, if you want to apply for it, you can contact this particular number or contact the Edvantage guys. Apart from that, if you want to know more, the code is also available on my GitHub. If you can go to my GitHub also, I'll share the link. So there are different projects that I do and upload on GitHub. You can follow that also. Okay. So yeah, any doubts? Now the stage is open for you guys. Any doubts, anything, any particular thing, any related to any topic if you guys want to ask. First of all, is the things means the things that we discussed. Is it clear that what exactly we wanted to do? Bittu, is it clear to you what exactly we want you to do? Great. So now if you guys have any doubt, you can ask me. And if you don't want to ask me right now, we can also connect on LinkedIn also. Share LinkedIn profile. We can also connect on LinkedIn if you don't want to ask right now. But if you have any doubt, not only related to predictive maintenance, any doubt related to AI, data science, or anything, or what you can say, how to start your journey in AI, you can ask. Okay, silent. Everyone is silent, which only means two things: either you are guys are very intelligent, you have understood everything, or you haven't paid attention enough in the class. Okay, we do great. Any doubt, guys? No doubts? No doubts at all? Okay, two doubts. Bacilo is asking, what is the common feature of machine failure from data and from plot? Common feature. There was not actually the common feature was not exactly visible from the eye that which one was a common feature. But if you see this particular scenario where we used this random forest for getting the features, from this thing was clear that this sensor 0 and sensor 6 were having a lot of things common that may have resulted that is kind of getting the that was having the information about the failure. Mustafa is asking what is the best way to learn data science. Okay. The starting point is learning Python. If you want to get into data science, the starting point is learning Python. Then learn statistics, little bit of mathematics. If you are from engineering background, so I hope your mathematics will be good. If these three things are achieved, Python, mathematics, and statistics, you are 70% of data scientist itself. What is the minimum data required to make prediction of failure? More the data would be your algorithm will be, because we have used LSTM cell, that is a deep learning cell. You can assume, you can say that your deep learning algorithms are have a hunger for data. So more the data you provide to them, greater result it will give. There is no any such particular point that okay, only in 1,000 data. If I don't have 1,000 data, my model will not perform well. Now to take an example, if there is something, if failure is happening, and if you are able to capture from your eye itself that okay, there is a chance that in this sensor there is a failure. And for that type of situation itself, 200 to 300 data points are enough. But if you have we are not able to visually catch it, or there is something happening in the data itself, so a lot of data is needed. Okay, Mukabbal. Okay. How many of you guys have some coding background? Means how many of you guys have coded once in your life or some time? Means I've done some even print hello world in any language. Okay, between learning coding. I assume you are a student, Vitu, right? In our JPT. Claude, you have a lot of background. So you don't have some background. I hope that you now knows a lot of things, Claude, right? Please correct me if I'm wrong. Mukabat is saying I'm learning ML engineering right now. I have coding experience in MATLAB, Python, Java. Great, great, Mukabat. Only random forest usually used for such forecasting. No, 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 no. Random forest is never used for forecasting. There is a difference between forecasting and regression. Random forest you can use for regression or classification. Forecasting terms comes into picture when there is a time series data. Only a time you can look forward in time, right? Random forest doesn't help you to look forward in time because it hasn't captured the relationship with the time. So for looking in time, there are different methods like statisticals or ARIMA or mass ARIMA like that. Deep learning methods are RNN, LSTMs, transformers. Even if you guys know GPT, that is also a transformer model. GPT also, ChatGPT, how many of you knows? Mukabat, do you know ChatGPT? I hope you know. I'm assuming you know. So ChatGPT, if you see, that is also forecasting the words, right? I use it every day. Great. That is ChatGPT is also forecasting the word by word, right? So similarly, time series data also works. And three is saying maybe you can take us through Python, sir. Sure, sure. Also help for assignment information. Yeah, ChatGPT also help for assignment college. You're right. Not in college. In every field itself, ChatGPT has helped. A lot of new companies have started by using the GPT API itself. You guys know you can use the GPT API for doing your work itself. You can create your own product using the API of the GPT. So is it different from ML? Yeah, little bit different from ML, but if you go inside the under the hood of every algorithm, there is nothing but mathematics. So if I tell you GPT, just see the name of GPT. What GPT is, full form of GPT. Ah, that generative pre-trained transformer. Okay, so there is a transformer here, right? And generative because it is generative. So transformer, if I tell you what exactly is transformer in terms of mathematics, transformer uses a concept known as attention. Attention. There were some guys in Google who released a paper in 2017. The name of that paper was "Attention is all you need." Okay, attention is all you need. So GPT uses this attention only. Okay, and what is attention? Attention is nothing but dot product. You guys know the dot product? What is a dot product? dot product that we have studied in vectors, physics, or mathematics also, right? So tension only uses dot product. With a lot of different things are also there, but at the core of the transformer is the dot product. Okay. So when you go in the core of the things, you will find out that okay, some type of mathematics is there that you have learned during your high school or some college. Nothing else. Okay, guys, any doubt or anything else you guys want to ask? Or shall we conclude the session? Thank you for your words, Claudia. Your words, it really means a lot. I mean, from uh, student word, I will not use Claudia for you. You are not student. We discuss the things, and there are no students. Everyone who is present in the class or session is present. So we can say, uh, guys, please. Whoever is present in any class or session are basically the people with whom we discuss the things. So student word is not right to say. Okay, guys, then keep learning. Take care. Bye bye.
Thank you, sir. Thank you for your time, sir.